So, um, this is question number 7. Wait a second. Okay, the diagram below shows squares ACEF, ABHG, and BCDI, three different types of squares. The large square shown has side AC equals 20, AB has length 15. Show that the perimeter of the shaded shape is 70 centimeters. Alright, so we know that perimeter is basically the sum of all external sides, right? External sides. So first things first, we have to know what the external sides are. The first external side is this one, that is of 20 centimeters, right? The second external side is this one, which is of 5 centimeters. If this length is of 5 centimeters, so automatically I should know that this length is also supposed to be 5 centimeters, right? This length will be 15 centimeters. The length of GH, and adding on the length of HI, that is also going to be, wait a second, 20 minus 15, no, 15 centimeters, yeah. And this length is also 15 centimeters. So essentially what are we supposed to do? We are supposed to add up all the bounding segments as it is. So you have 20, 5, 15, 15, 15, 5. So if you were to add all of them together, we get 45 plus 25, or 50 plus 25, which is 75 centimeters. Alright, do calculate it and tell me if you're getting the same answer as well. Wait, we should show that it's 70 centimeters. Wait a second, where did I go wrong? Which part did I add by mistake? 15 plus 15 plus 15. Oh, sorry. This length is supposed to be 10 centimeters. My bad. Right? So, one of them is going to be 10. So, if we were to add all of these together, we would get an answer of the length, the total perimeter being 70 centimeters. Alright? That's how we calculate the external area, external perimeters.
All right.
Alright? Okay. Let's move forward then. Um, On the simulator below, use the slider to change the length of AB and see the corresponding length of the perimeter of the shaded shape when AC equals to 20 centimeters. Alright, let's have a look. I think it's going to be done later on. Write down the missing values in the table when the length of AB is L equals 14 centimeters. So that's pretty straightforward. The value should be 20 minus 14, which is going to be 6 centimeters, or we can have a pattern in front of us. And that pattern is that each and every value is basically essentially decreasing. And if we want to talk about the perimeter shape, so that is definitely going to be 60 to 62, then 62 to 64, 64 to 66. Of course, so there is going to be a difference of positive 2, right? We can see that. So here the value is going to be 68. Then it says write down in words a pattern from the table for the perimeter. Alright, for the perimeter. So we can say that as the length of L basically increases, the length of AB essentially, when it increases by 1 centimeter, the perimeter essentially increases by 2 centimeters. That's quite evident here in front of us. Alright, so we can say as AB length increases by 1 centimeters, the perimeter of the shaded shape increases by 2 centimeters. Make sense?
Yep.
That's great. Alright, focusing on part D. You see, part D was a bit confusing for students. And this is what we are essentially learning. Whenever we solve questions related to sequences, I told you that our answers should always be in the form of a plus n minus 1 multiplied by d, or n square, an square plus bn plus c, depending on what type of a sequence there is. So if there is a, for example, a quadratic sequence, the answer should be in the form of an square plus bn plus c. And if it's a linear sequence, it should be a plus n minus 1 times d. But the difference comes that the questions are not going to be always like this. Because it's in 8 part D, it says that you have to find the general rule for perimeter in terms of the length. Okay, so this is a twist. But how do we attempt this question? First things first, let's try to find the general rule of the perimeter in terms of n, the way we normally do. We have 60, 62, 64. So when we solve it with the reference of a plus n minus 1 multiplied by d, we know that the principal term a is of 60. Okay, plus let n remain as it is, and the common difference is going to be 2. Yeah, positive 2. So if you were to multiply it, we get 60 plus 2n minus 2. 2n, 60 minus 2 is basically 58. So 2n plus 58. So as of yet, if someone solves it like this, they're only going to get 1 mark. Why? Although their answer is correct for the perimeter, if I substitute values, I do get the right answer. But here it says it in terms of length. So what change do we have to make? In terms of length, if it says, so we have to substitute the value of n with L. So it should be 2L plus something. It cannot be 58 anymore. Why? Because the value of L is 10. It's 11. It's 12. So you see, it's not 1, 2, and 3. It's not going linearly in that way. All right. So what do we do in this case? Let's try to substitute the value of L as 1. And that means in that case, the value of P is supposed to be 60 centimeters. All right. So we have 2 multiplied by 1 plus X equals 60. 2 multiplied by 10. My bad. L equals to 10. So If you want to find the value of x, we get 20 plus x equals 60, and x equals basically 40. So our value of L is essentially going to be, if it's 10 and the perimeter of the shaded shape in total is of 60 centimeters, so our value should be 2L plus 40, as x is going to be constant in this case. And we can verify and test this rule as well. For example, if L equals to 12, so 2 multiplied by 12 plus 40, this becomes 24 plus 40, which is essentially 64. And here you go, our answer is proven. So our general rule is going to be 2L plus 40. Make sense? Verify your general rule. Okay, verification part. So this can be done pretty easy as well, right? So you have to basically use the values of, ideally you should use the value of 14, L equals to 14. So 2 multiplied by 14 plus 40, that gives you a value of 28 plus 40, which is 68 centimeters. Alright, and just like that, you can use L equals, for example, 12. So 2 multiplied by 12 plus 40, which becomes 24 plus 40, which is 64. So here we go. This is basically the verification part. I hope this was not too confusing. Have you written this down?
Yeah.
Alright. Okay. The diameter AB, wait a second, did they, I think, yeah, they might have. This is an example of a simulator. Let me just move this upwards. Okay, so it says that the diameter AB is 100 centimeters. The radius of the semicircle AC is 30 centimeters, and the radius of the semicircle CB is 20 centimeters. The diagram is not much to scale, honestly, somewhat it is. So that the perimeter of the shaded shape is 100 pi. Hmm. Okay. So what has been given to us? We know that the entire length from A up till B, I want you to first understand this, has been given as 100. AC has been given to us as 50. And CB, wait a second. Wait, AC has been given as 30 centimeters. My bad. I just added both of them together. Wait, I'm doing something wrong here. This is what needs to be done. Yeah, this is 30 centimeters, and this length was of 20 centimeters. Okay, this is what the information that we have. Now let's try to calculate the value of the perimeters. All right. Now the perimeter is basically what? It is the sum of the arc lengths of all three semicircles. Okay. So essentially speaking, the total perimeter, the total perimeter is essentially going to be this entire part plus this region plus this region, right? So what's the formula that we usually use for perimeters? It's going to be 3 multiplied by 2 pi r. But the value of radius is going to be different. The value of the radii of each is going to be different. Focusing on the largest one, 2 multiplied by pi multiplied by this entire had a radius of 50 centimeters, right? Okay. So that was for the largest arc length. Then, hmm, okay. So that's basically, wait a second. If I'm doing it like this, okay. Let me do it one by one. 2 pi r plus 2 multiplied by pi multiplied by 30 plus 2 multiplied by pi multiplied by 20 as it is, right? But the issue is that the formula for the perimeter that we use, 2 pi r, that is for a circle, an entire circle. We don't have an entire circle here with us. We have a semicircle. We have half of a circle. So what do we do essentially? After we calculate all of the values, when we get the final answer, we should divide that value by 2. So this becomes 100 pi, this becomes 60 pi, and this becomes 40 pi. All of this is equivalent to 200 pi. But that's not the final answer, right? Because we have to divide that value by 2 because this is a semicircle. So 200 pi divided by 2 gives me an answer of 100 pi, and hence that's how we calculated the perimeter of the shaded shape as 100 pi. Make sense?
Yep.
Okay. Okay. So we should essentially, what are we supposed to do? Investigate the relationship between the radius of semicircle CB and the perimeter P of the shaded shape when the semicircle AC is 30 centimeters. Okay. You may use a simulator above in your answer. You should predict more values for P, write down in words any patterns you see for P, so on and so forth. Okay, let's do it one by one. Without a shadow of doubt, the larger radius is supposed to remain same, right? As it is being a constant in this case, right? Because as it says, you see, whenever we study independent and dependent variables in sciences, right, you might be well aware of it. So one thing is what we're supposed to calculate, and the other things are a few constants or the things that are independent of each other, right? Okay, so that's how we know that the value of the major R is going to be 30 as it is. What about the value of minus R? First things first, let's finish this prediction. So, of course, the value is increasing by 5 each and every time. So, this becomes 35, this becomes 40, this becomes um, 45, and this becomes 50. And of course, the values here are increasing by 10 pi each and every time. So this becomes 110 pi, this becomes 120 pi, 130 pi, 140 pi, 150, and 160 pi. So this was our part for the predictions. Is there anything else? Not really. All right. So then it says, write down in words any patterns you see for P. So if you want to describe this in words, the best way to do it is to relate it by another variable that was already given before, right? So how do we do that? That's pretty simple. That can be done by looking at what is the value of R. So for instance, I can say that for the pattern part, as the value of R increases by 5 centimeters, the perimeter P increases by 10 pi. One pattern is sufficient, I hope. I don't know. Let's just write one more about it. That can be one pattern, all right? Another pattern that we can also possibly write, mm, what can be another pattern? Let's have a look. We can also say that for every unit increase in R, for every unit increase in the value of R, the value of P increases by 2 pi. This was a bit technical to understand, but I'll give you an example. So look, 80 pi minus 70 pi, if that was divided by 10 minus 5. Why? Because when the value of R is 10, the value of P is 80 pi. When the value of R is 5, the value of P is 70 pi. So that becomes 80 pi minus 70 pi, this becomes 10 pi, and 10 minus 5 becomes 5. So 10 divided by 5 is essentially 2, and pi remains as it is. So for every one value that R is increasing, the value of P is increasing by 2 pi. So we can also write this. For each one value that R increases, P increases by 2 pi. That could be one good method of writing the answer down. I hope this is clear to you.
Yeah.
All right. Write it down and then tell me once you're done. So we're done with the pattern as well. Find a general rule for the perimeter of the shaded shape P in terms of R. Perimeter of the shaded shape of P in terms of R. Okay. So the perimeter is basically 70 pi, 80 pi, and 90 pi. That's like this. So we know that this can be written as in the form of a plus n minus 1 time multiplied by d. So if you're solving it in that way, the principal term remains 70 pi, n minus 1 as it is, and the difference is of 10 pi. So we have 70 pi plus 10 pi n minus 10 pi, 10 pi n plus 70 pi minus 10 pi. This gives us the value of 60 pi. But you see, once again, what does it talk about? It says that the value should be given in terms of r, not in terms of n, right? What does it say? It says it should be given in the terms of r. So first things first, I know that. Let me just replace n with r. Simple. 10 pi r plus 60 pi. But once again, am I doing it correctly or am I not doing it correctly? Why? Because let's say, this is the mistake that most students might have made. They would have written it in this form, and then they wouldn't have been able to solve the next part, because the next part would have been of testing and verification, and that's why they test your knowledge. So if someone was to suppose as the value of r is 5, so the value of p should be 70 pi, right? So if I substitute this, 10 multiplied by pi multiplied by 5 plus 60 pi, I get 50 pi plus 60 pi, which becomes 110 pi. But I'm not getting this, right? I'm not getting 70 pi, I'm getting 110 pi. So where am I going wrong? I'm going wrong because I'm unable to convert the value of pi into what I need. So how do I solve this question? Look, I can say that the value of r should be essentially the same thing, a number, a specific number that can multiply to give me 10 pi. So if the value of r is 5, if the value of r is 5 and I want my final answer to be 70 pi, what I can do is that I can simply consider this answer as 2 pi r plus 60 pi. What I'll do, I'll just divide 10 pi by 5. So I'll get an answer of 2 pi. And this is going to be our correct answer. 2 pi r plus 60 pi. Make sense?
Yep.
Okay. Write this down. And I think the next part is going to be prove or verify. Okay, test your general rule and justify your general. Okay, we'll test it and we'll justify it as well. In order to test this value, I should substitute the value of r as 5 or something that was already given to us from before. So when I substitute that value, I get 2 pi multiplied by 5 plus 60 pi. I know that 5 times 2 is 10. So 10 pi plus 60 pi should give me an answer of 70 pi. And I can see this in my table above, that when the value of r is 5, the total perimeter is going to be 70 pi. And just like that, if the value of r is going to be 40, this is the verification part, the one that we solved later on. So now equals 40, 2 multiplied by pi multiplied by 40 plus 60 pi. This becomes 80 pi plus 60 pi, and that gives me an answer of 140 pi. So this is also true. You can write this down and then we'll solve the justification part ourselves. Okay. The last part says that we have to be essentially justify our general rule, the one that we had found of 2 pi r plus 60 pi. We have to justify that. Okay. So have a look. The arc of AC, which is basically the inner semicircle, it has a value of 30. So essentially what's happening? This is not changing, right? What's happening is that the value of small r, that was changing. So initially it was something else, and now we have different various values, and we just solve a table for it. So I can write this as simply 30 pi. Like there's no disagreement on it. As far as the inner semicircle of CB is concerned, um, in order to find the value of their circumference, I should introduce the formula pi r, because of course pi is going to be constant, but r is not going to be constant because r is changing, right? The one that we had seen above. So if I want to find the value of the total diameter from A to B, what is it going to be? Total diameter equals diameter AC plus diameter CB. Alright, these are the two diameters that we need to essentially find. Now, if you want to find the radius of the outer semicircle, the radius of essentially this, this is the semicircle, and this is the entire, half of it is going to be the radius, of course. So how to find that radius? That radius is going to be the one that we have found above, simply 2r plus 60 over 2, or that becomes r plus 30. And since of course the value of pi is going to be added to it, so this becomes pi r plus 30 pi.
Correct.
Alright? But this is not the total perimeter. This is still, as of yet, it's just the large outer semicircle arc. This is not the total perimeter. The total perimeter is going to be the outer arc plus the two inner arcs. This one as the one that we calculated above, this one, and these two, the ones that are inside. Let me do it with a white colored pen, so that's a bit more visible. These two. So how to do it essentially? 30 pi plus pi r plus a combination of it once again, because essentially both of them are equal to each other. 30 pi plus pi r. So what do we get? I am getting 60 pi plus 2 pi r, and that is exactly the value that I had above, 2 pi r plus 60 pi. So this algebraically justifies and proves that the entire perimeter should be equal to 2 pi r